right, welcome geometry. We're jumping into lesson 68 this week, and we're looking at an unusual concept. If you haven't done it before, we're looking at trig ratios. Now, what is a ratio? Well, a ratio is simply when we compare two numbers, right? So a ratio. Now, one thing that's super important is to think through that whole gate principle, right? So if I have a swinging gate here, let's say that this is where the gate is supposed to close. Here's my fence, right? And so here's the gate, right? So if I open the gate wide, then I've got this angle that's formed, right? And this angle that's formed directly relates to how wide of an opening is opposite it, right? That's the whole gate principle. So the wider that I swing that, so, a small person could walk through that. But let's say that I were taking an animal through that gate. Maybe I was taking a livestock or something like that. That opening is not going to be wide enough. So what am I going to have to do? I'm going to have to change the opening, right? So that opening, I'm going to have to swing the gate a lot wider. So here's the width of that. That's going to directly relate to how wide this opening is, right? That I can fit something through. So the size of the angle directly relates. Let's think about if I have this super small obtuse angle. Well, because it's small, it's going to directly relate to the angle across from it. Now, let's say that I have an obtuse angle, right? Like this one's a massive, right? It's obtuse. Well, to join those two, I don't even know if I can join those two. All right, I had to turn it a little bit. That's a massively long side because this angle opposite is obtuse, right? So in doing that, down through time, mathematicians have discovered that whole gate principle. The wider the angle, the longer the opposite side has to be. So we have what's called trig functions. Now, one thing I want to really emphasize with you guys is that trig functions can only be used with right angles. All right, so sine, cosine, and tangent is our trig functions: sine, cosine, and tangent. Now, this is how we abbreviate it: sine, cosine, and tangent. Now, I've had a few students say, Miss Kim, that's sin. No, it's sine. It's spelled S-I-N-E. But if you grab your calculators right now and look for the button, it's going to have S-I-N. That means sine. Sine, cosine, and tangent. Those are three trig functions, and they can only be used when we're dealing with a right triangle. All right. Now, there are a lot of things that can only be used with right triangles. Let's review a couple of those. The Pythagorean Theorem, a squared plus b squared equals c squared. That can only be used with a right triangle, right? So this is another concept that can only be used with a right triangle: sine, cosine, and tangent. And it's a ratio of relating the angles and the sides that make up a triangle. I remember teaching this concept to a student, and that student felt so overwhelmed with sine, cosine, and tangent. And I can still, even to this day, remember hearing that student say, "But Miss Kim, what is it?" And I would say, "Well, it's a ratio." And they'd say, "But what is it?" They wanted to physically touch. What is this? How can I use it? What is it? Well, a lot of times when I approach math, I think of it like a tool belt. If I were a carpenter, or I were a construction worker, or a contractor, I would go into a house and I would say, okay, I've got all my tools here in my bag or on my tool belt. What am I going to use to fix this? Now, there's a game. Sometimes I'll be playing a game on my phone or on my iPad, and up will pop these commercials for things. And there's one game that comes up all the time, and it's like all these problems that someone has. Have y'all seen that? And the commercial is like this faucet is going off, and they offer you different tools. And like one of them is something crazy. One will be a wrench, and then one might be like a fire extinguisher. Well, why would you use a fire extinguisher if water's going everywhere, right? But you have to choose what tool you're going to use, and then it tells you whether you passed or failed. Well, the same concept is true when you're doing math, is you approach each problem and you think, okay, what tools do I have that can help me solve this? The great thing is each of you guys could look at it a different way and say, well, I know this side and I know this side. It's a right triangle. I can use the Pythagorean Theorem. Or someone else might say, well, I know this and I know that it's a 30, 60, 90 triangle and I know the shortcuts. So I know that, so I can use it. Well, this is just another tool that we can use for our tool belt. So sine, cosine, and tangent are 3 trig functions, and they can be used to help us to solve right triangles. Now, my teacher, I can still remember when I learned this in high school, and he actually came in dressed in Indian headgear. And I love you guys, but I am not coming to my Zoom meeting dressed in Indian headgear. But he told us a little acronym to help us remember it, and he would always do it in an Indian sounding way. But it was called Saw Ka Toa. And he would always make that sound. He would go, oh, Saw Ka Toa. And it's funny, but I never forgot it. Now, I've actually heard other students tell me, teachers who have given them an acronym to remember that, but I just remember saw, O-H, and then ka, A-H, and then toa, O-A. Now, what's super important is each of those are attached to it. So the sine of an angle is the opposite over hypotenuse, and that's how I remember it. So the sine is a ratio of the opposite side over the hypotenuse. So if I'm looking for the angles or a side, I can use the sine ratio. So the sine of an angle equals opposite over hypotenuse. And remember, the hypotenuse is the side opposite the 90 degrees. Cosine of an angle is adjacent over hypotenuse. So what side is adjacent? It's the one that's touching it that's not the hypotenuse. All right, so cosine is adjacent over hypotenuse. So sine and cosine both have hypotenuse in the denominator, but one is the side opposite it and one is the side touching it. And then the last one is tangent. And tangent is the only one that does not use the hypotenuse, and it's opposite over adjacent. Now, I know you're going to say to me, Miss Kim, does it matter if I, maybe put adjacent over hypotenuse? Yes, that does matter. That's actually the inverse tangent. So that's why it's important that you understand what these relationships are and then how to use them. So that is very important. So these are our trig functions. If you look on page 451, it has them written out for you. It also shows you a triangle, triangle STU, and then it talks to you about what the sine, cosine, and tangent of it would be. So let's turn to page 452, and it gives you some examples, more triangles, and then it asks you. Now, example 2 shows you how to calculate them on a calculator. If you'll look on the page, middle of page 452, it says, what's the cosine of 52? Friends, all you do is grab your calculator and type in the button, cosine 72 equals. Now, one caution I want to give you. I had a student one time. They were in tears. Miss Kim, I know what you're teaching. It sounds so easy. I can't get the right answers. And I'm telling you, they were so frustrated. I looked at their calculator, and you know what I found out? They had their calculator in the wrong mode, my friends. Miss Kim, there are modes of a calculator? You bet. Because in upper level math, sometimes you'll deal in what's called radians. So most of the time, if you get a new calculator, it comes standard from the factory in degree mode, DEG. And some, especially scientific calculators, will have that written at the top, DEG. You should be in degree mode. You will not use radian mode until like pre-calculus, calculus. All right. So for most of high school math, you'll use the degree mode. So be careful. If you type in cosine of 72 and you don't get 0.31, you're in the wrong mode. Okay. So that's just a quick reminder there. All right, and then they have a few more examples for us. Look at example 4, page 453. Use the sine ratio to find x to the nearest hundredth. One thing I want to point out to you is anytime I use sine, cosine, and tangent, I'm going to have to end up rounding. So notice on example 4, it says x is approximately. Notice the wavy x. So it's not a precise answer, so I have to round it. How did they find x? Well, x is the hypotenuse. So 32, I would say sine of 32 equals opposite over hypotenuse, 8 over x. Now you can cross multiply and you would get x times the sine of 32 equals 8, 8 times 1. Then you would divide through by sine of 32 and you end up x equals 8 over the sine of 32. Type that in your calculator, 8 divided by the sine of 32. I would encourage you to do that right now just to make sure that your calculator is in the right mode and you're solving for the right answer. 8 divided by the sine of 32. And you should get 15 point blah, 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 blah. And then you round it to the nearest hundredth, which is approximately 15.10. Okay? Let's do some practice together, friends. Let's look on page 453. What is the sine of angle T? All right, now bear with me because I'm actually going to erase my itty bitty board. My big board sprouted legs. I have no clue where he went to. I could say my dog ate it and it might be true. All right, so I've got T, V, and U. I've got 5, 12, and 13. All right, so this is what practice A looks like. It says, what is the sine of angle T? Well, let's go to angle T because all depends on your perspective. If I'm standing at U, the sine of U is going to be different than the sine of T. So I'm standing here at the sine of T, and I'm looking for the sine of angle T. So the sine of angle T, let's remember what is sine. Saw, ka, toa. I'm going to write that here. Saw, ka, toa. All right, so sine is opposite over hypotenuse. Opposite over hypotenuse. So if I'm standing at T, what's opposite T? 12. So the sine of angle T equals 12 over, what is the hypotenuse? Hypotenuse is over 90, 13. So my answer, the sine of angle T is simply 12 over 13. That's it. That's your whole answer. Letter B, what is the tangent of U? Well, now let me get a different color so that way we're not getting confused. So if I'm asking what the tangent of U is, I'm standing at a different place. My perspective changes, right? I'm standing at U. So it's asking me what's the tangent of angle U. If I'm standing at U, let's go back up, tangent. All right, so tangent is opposite over adjacent. So tangent, we said, is the only one that does not have hypotenuse in it. So the tangent of U is opposite over adjacent. All right, so the tangent of angle U is opposite over adjacent. So what does that look like? Well, if I'm standing this time at U, opposite of U this time is 5. See, opposite of T was 12, so opposite of U is 5. All right, so let's write that. So the tangent of angle U equals 5 over, now let's look at U. There are two sides touching U. It has to be the side that's not the hypotenuse, because remember, tangent doesn't have hypotenuse. So that would make it 12, not 13. 13 is the hypotenuse. So it is 5 over 12. Okay, that is the tangent of U. Now, letter C says, find x to the nearest hundredth. So x is in the second picture there, second diagram on page 453. So it's asking you, how do I find x? Well, in order to figure out how I can find it, think, what information have they given me? So my triangle looks something like this. I know you're probably laughing at home going, oh, that's not 90 degrees, but pretend with me. All right, so we're going to pretend that this is 90 degrees. You all can smile at home. All right, so I need to know what is x. Well, they've told me, and I'm sorry that's squashy there, it's 39 degrees. So if I'm standing here, the hypotenuse would be here. So what information have they given me? They've given me opposite and hypotenuse. Well, which one is opposite and hypotenuse? Sine. So I would say the sine of 39 degrees equals x over 41. So that's how I'm using sine, cosine, and tangent. I use what they've given me, and then I try to figure out what ratio can I use to solve this with. Well, because they gave me 39, opposite over hypotenuse. All right, now some of you may say, well, Miss Kim, if I know that that's 39, can I figure out the other one? Absolutely. If that's 39, well, every triangle is 180, minus 90 is 90, 90 minus 39, and I could solve over here, and then I could even use cosine, but I'm just simply using the one that they gave, okay? Now, how do I solve this? I just make it like a proportion. Sine of 39 over 1 equals x over 41. Cross multiply 1x or just x equals the sine of 39 times 41. One thing I want to caution you is when you plug this into your calculator, be careful to close your sign. Typically when you press the sign button, up will pop parentheses. If you don't put end of parentheses at the end of 39, it will think you're still finding the sine of 41 also. So you're only finding the sine of 39 and then multiplying that answer times 41. So watch your order of operations there. Or you could always press sine of 39 equals, then multiply it times 41. But you want to make sure you get that answer. All right, looking at the rest of page 453, you can easily plug these in. Grab your calculator. Sine of 30 equals, boom. Cosine of 90 equals, boom. Tangent of 41 equals, boom. Make sure you solve that. Now, I see sine of 30 is in your example 2 is 0.5. So you've got 2 more you need to do at home. All right, let's look at letter G. A playground has a slide that is at a 38-degree angle with the ground. So they've given you a picture there. So here's your slide. All right, and it's 38 degrees with the ground. If the slide is 16 feet long, what is its height? All right, so I'm looking for this. So it's given me 38 degrees. It wants to know its height, and you guys know this would be the hypotenuse. So that's important to know. So I'm looking, if I know 38 degrees, I'm looking for opposite and hypotenuse. Again, the sine of 38 equals x over 16. How did I know that? Because I'm standing over here at 38, opposite and hypotenuse. It's not the one touching it. It's not adjacent. So that's how I solve it. Now again, just make it a proportion. So all you have to do is cross multiply. 1x or x equals the sine of 38 times 16. And at home, I hope you're plugging these in. I don't have my calculator with me to work them out with you, but it's very basic geometry that you're using for these. So make sure, again, that you're closing your parentheses, and that's all you're doing. So that's all of lesson 68 for us there, friends. Simply a good reminder of sine, cosine, and tangent, and then how those work together. So I think that's great. All right, turn with me to lesson 69. Lesson 69 is all about the properties of trapezoids and kites. Quite frankly, you do not use trapezoids and kites, especially kites, as much as you'll see rectangles and squares, and of course parallelograms. Those are going to be the most common that you see in standardized tests. Now, occasionally a trapezoid is because you still have those one set of parallel sides, but you do need to know these. You just probably won't use these quite as much as you do other quadrilaterals. All right, let's look at your theorems on page 457. The midsegment of a trapezoid is parallel to both bases, and has a length that is equal to half the sum of the bases. So let's rewrite that in everyday terms. All right, so because trapezoids have exactly one set of parallel, if you find the midpoint of those two, it's going to be parallel to the other two, right? If two are parallel, you add another one that's halfway in the middle, it's parallel, right? Now, how do I find the length of that? Well, add the two bases, divide by 2, and that's your mid segment, okay? So that's all that they're showing you there. Turn and look at page 458, example 1. So they show you that AB is 15, DC is 25. I add those two together, take half, and I find the mid segment, EF. All right, pretty basic and sounds pretty easy. Now, what's the properties of an isosceles trapezoid? Isosceles, I saw 2, right? So that means that the opposite sides are congruent. Sorry, I had a brain freeze and I couldn't think of the word congruent. You can't come to geometry class without remembering the word congruent, right? All right, so it says if the base angles of isosceles trapezoid are congruent, then it's kind of showing you a picture there. So notice it has K and J are congruent, then H and I are congruent, and then opposite sides, HK and IJ are congruent. And part of that is because the whole transversal idea of two lines are parallel, so when they cut down through, those alternate interior, those kind of relationships are formed. All right, look at example 2. So it said because the trapezoid is isosceles, its bases are congruent. So notice PM and ON are congruent. So if I know that angle M is 107, then I also know that N is 107. Okay, and then I know that P and O are congruent to each other as well. So I can figure those out because they are supplementary. So 180 minus 107 would give me what P is, and whatever P is, O is as well. So that's on page 458. Now, properties of isosceles trapezoids. It shows us that the diagonals are congruent, and we've seen that in other quadrilaterals as well. Look on page 459, properties of a kite. The diagonals of a kite are perpendicular, meaning that they intersect at 90 degrees. And that picture right there looks like the very common kite that every kid has, right? Well, I'm not sure about every kid. Sometimes kites can be dangerous, right? We've bought some for my kids that are a little bit flimsier than expected. So, but it is a lot of fun trying to fly a kite, right? Can also be frustrating too, can't it? All right, so they show you how those diagonals work because they're 90 degrees. So you can, obviously they used the Pythagorean Theorem because a squared plus b squared equals c squared. Since you know that they're 90 degrees, a lot of things open up. So if you ever see that on a standardized test, given this is a kite, given these are diagonals, then you immediately know that you can use things like sine, cosine, and tangent. You can use the Pythagorean Theorem. All right, there are several examples for us on page 460. Let's look at our practice. Practice A. EF is the mid-segment of this trapezoid. Find length CD. All right, friends, they mixed things up a little bit for us there, didn't they? Well, let's go back to what we know, all right? All right, so this is a trapezoid. All right, and they told us that it's a trapezoid, and we know this, but they said AB is 22, and then they told us EF, which is the mid-segment, is 38. They want to know what DC is. All right, so I drew the best picture that I could. You'll just have to pretend along with me that it's as close as possible. Now, we know that if I add AB, segment AB, plus DC, it will be the final answer. If I take 1/2 of this, it will be EF, right? So I add the two, the top and the bottom, add them together, divide by 2, or multiply it times 1/2, same thing. That gives me EF. Well, let's go backwards, all right? I know that AB is 22. I know that EF is 38. How am I going to solve for DC? So I plugged in everything I know. 1/2, 22 plus DC equals 38. Go backwards, right? If I multiply this by 2, that's going to cancel this out and give me 22 plus DC equals 38 times 2. 8 times 2 is 16. 3 times 2 is 6, plus 1 more is 76. Now I'm going to subtract 22, and that will give me DC. Do you see, friends, that they've gone backwards? In our practices, they gave us AB and DC. We just had to add them together and divide by 2. This time they gave us one, but not the other. So DC equals 54. Now, is that reasonable? Absolutely, because it should be bigger than the middle, right? So 54 plus 22, if I half it, it should be 38. So great job. That's practice A. All right, great job. I hope you're taking good notes on this. All right, letter B, find the measure of Q, S, and T. Well, it told us it's an isosceles trapezoid. Well, if it's isosceles, then its bases are the same. So if R is 48, friends, so is S. So angle S equals 48 degrees. How do I figure out what Q and T are? Well, angle Q and angle T equal 180 minus 48. So all I have to do is find out what 180 minus 48 is, and that is the answer for both Q and T. All right. Now, letter C, it says the isosceles trapezoids, MNOP. Now, it says find the length of MQ. All right, hang on, I'm sorry. My board has ran out of room, so I'm going to have to erase all this and then find a little bit more space. All right, so again, we're on letter C. Now, it's telling us that this is a lot like example 3. Notice you'll see that there on your page. All right, so, all right, let's draw a picture of that. So it's an isosceles triangle, or excuse me, not isosceles, isosceles trapezoid, my friends. I'm on the wrong shape there, aren't I? Okay, and how I know it is because they told me the sides are the same. All right, let's take a look. So it's asking us to find them. Find that length. So we know that the diagonals are congruent. So if I know that, find the length of MQ if NP is 17.5 and then PQ is 9.6. So it's asking what MQ is. Well, I know that the total would be 17.5. So all I need to do is say 17.5 minus 9.6. So it gave me the whole. So it told me this whole was 17.5. Then it told me that this part was 9.6. Well, I need to know what these smaller parts are. So in order to figure out the smaller parts, all I have to do is subtract 9.6. How do I know that? Well, in my theorem, it said on the bottom of page 458 that the diagonals of isosceles trapezoids are congruent. So since they're congruent, I know that both of them are 17.5. So I just take the smaller part and they are congruent as well. So my answer is 7.9 yards. Don't forget your label there. All right, letter D. Find the lengths of the sides of the kite. Now, I know that the kites intersect at 90 degrees. So I can use a squared plus b squared equals c squared. and it says round the lengths to the nearest. So if you look at FG, that side there, that's going to be the hypotenuse. So I could say 2 squared plus 4 squared, and I could easily solve that. 2 squared plus 4 squared equals FG squared. So just in solving letter D. So 4 plus 16 would be 20. So the square root of 20 is FG. So what is the square root of 20? If I round it to the nearest, it says round to the nearest 10th. So that would be approximately 4.5. So FG is approximately 4.5. It does not give a label, so I would just say 4.5 units. So that's how I solved it, because it was square root of 20, right? So square root of 20. Now, if FG is that, then also FJ is the same, and because that's the properties of a kite. So we just found that this is 4.5 based on this is 4 and this is 2. Then also the same is true down here. So this is 4.5, right? So now all you're going to have to do is find the opposite ends of the kite as well. So we found 4.5 and 4.5. So now you just have to do the same thing, and you can use 2 squared plus 7 squared and figure out what GH is, and then solve. All right. So those are just some properties on lesson 69 that you guys are going to use for solving different ones. All right, I'm going to let you do the last one on your own. So we've done several practices together on lesson 69. All right, let's jump into lesson 70. All right, lesson 70 is all about finding surface area and volumes of pyramids. All right, so how do I find the volume and the surface area of a pyramid? Well, remember before we talked about the volume is the area of the base times the height, right? And that's for, if I'm finding volume of a, if I'm finding the volume of, excuse me, I'm grabbing my shapes. All right, so if I'm finding the volume of any kind of shape that has the same base and same height, then I just find the area of the base and multiply it times the height. So in this case, it'd be length times width times height, right? Now, what's different with a pyramid? Well, let's talk about that. A pyramid is going to take place when the base is one shape and it comes to a point. So, how do I find the area of a pyramid? Well, I still find, so if I'm still looking for that area, or excuse me, that volume, what am I doing? Well, I'm having to take away some of the volume because it doesn't follow the same base. It comes to a point, right? So your book shows you here that you take 1/2. Oh, they're showing you that's the lateral surface area. I'm sorry. So the volume, how do I find the volume of it? Well, it's the exact same thing that we talked about here, only I take 1/3 of it. All right. Miss Kim, why 1/3? Well, think of it this way. If this point came up, it would be here. And if this point came up, it would be here. So I'm taking 1/3 of that shape because it's coming to one point, right? And you can have a rectangle. That is a triangular pyramid, but you can also have a square pyramid. So there are a lot of different shapes. I'm not sure what happened to my, so this obviously is a cone, but if you look at it, the base is coming here. It's missing 2/3 of it, right? Because it would continue to come up. So you're just taking 1/3 of it. So anytime you're finding the volume of any type of cone, you find the area of the base, take 1/3 of it, and multiply it times the height, okay? Or you can just remember that you can change the order. You can multiply the base times the height, just like regular volume, and then just multiply it times 1/3. Now, what's the surface area of a pyramid? Well, you're going to have to find the lateral surface area and then the base, depending if the base is a square, a rectangle, a triangle. In this case, mine is a triangular pyramid. So you're going to have to find the base and then add to it the lateral surface area. So that's what your book is showing you. And they've given you examples there. How to calculate the lateral surface area. You take a half of the perimeter times whatever the slant height is. L is the slant height. So you just have to follow your formula there and to solve it. So your book gives you examples on page 465 and 466 of solving those. All right, practice A. It says, what is the lateral area of a regular octagonal pyramid? Woo, that's a mouthful, my friends. Regular, all sides are the same. Octagonal, 8. Pyramid comes to a point. All right, so woo, there's a lot of things going on with lesson 70, isn't it? So go back to your formula. So my formula for, it says, what is the lateral area? That just means the distance around it. I don't have a picture of that, but it would be a base that's an octagon, like a stop sign. And a stop sign, all the sides are the same. So that's a regular octagon. And then it comes up to a point. All right. All right. So how do I find the lateral? It's just 1/2 the perimeter times the slant height. All right. All right. So it says, so that's my formula for the lateral area. And your book just calls that capital L. Okay. Now, what's the perimeter? Well, the perimeter would be 8 times 5. How do I know that? Because it says that the length is 5 centimeters and it says octagonal. So there are 8 5s. So I would have 1/2 times 40 times L, the slant height, is 7. So half of 40 is 20. And then 20 times 7 equals 140. And it gave me centimeters, so I'm going to say centimeters squared since it is the lateral surface area. All right. Okay. Letter B. What is the surface area of a regular hexagonal pyramid with a slant height of 8 inches and a base side length of 4 inches to the nearest hundredth of a square inch? All right, so hexagonal means 6-sided, right? And then it says, what is the surface area? Well, what's the difference in what we just solved and what they're asking here? Lateral is all the sides. So if it's asking for surface area of anything that's a pyramid, it's coming to a point, all that we have to add in is the base, right? So we've got to find the area of the base and the lateral, okay? So it says the side, and it's a regular hexagon. So 4 times 6, and I've got to do 1/2 times the slant height. The slant height was base side. So we actually, it did not tell us. Oh, the slant height is 8. I'm sorry, I missed letter B. All right, the slant height is 8. All right, so 1/2 of 4 times 6 is 24 times 8. So that would be 12 times 8 equals 96. And I solved that just by using my formula, 1/2 times P, the perimeter. I knew that it was a regular hexagon. All the sides were 4. And that's what it said in the directions. All right. Now, I've still got to find the base area. So how do I find the base of a hexagon? All right. So I know that a hexagon, all 6 sides are going to be 4. All right. And so I need to solve that. Now, how do I find, since the base is a regular hexagon with 3, its perimeter is, so it used that. Now, how do I find the base? Look on page 465, and it used side times the square root of 3 over 2. So I'm able to use that. It says the formula for the area of a regular hexagon, and that's a little bitty box under the hint. So the area is 1/2 A times the perimeter. So it's really important that as we solve those, that you all just use that formula. I'm not going to have time to finish because we've still got one more lesson, but there's your area. Since I know in this case that it is 4, I'm just going to plug that in. All right. So the volume, actually, which number were we on? I got sidetracked looking for our hint. And our hint was, again, if you all are looking at home, page 465, how to find the area of a regular hexagon, 1/2 A times P, your perimeter. So this is practice B. So it would be 1/2 2 square root of 3 times 24. And we just figured out 24 was that, was its perimeter, right? So we end up that the area of the base is approximately 41.57 inches squared because we just used that formula that was on the page. And then we found the surface area. We did that just a moment ago and found that 24 and 8 and 1/2 was 96. So 96 plus this together would be approximately 137.57 inches squared. So all you're doing is using those formulas there and solving, okay? Now, I do want to point out to you, there's just a couple of more practice problems there on that. I know we spent a little bit more time going over sine, cosine, and tangent, but just make sure you use your formula. And again, that hint on page 465, we have not done a lot with finding the area of a hexagon. And if you ever saw that on a standardized test, they would actually give you that formula as well. All right. Investigation 7, again, that's bonus points. If you guys turn that in, it's more on trig ratios, sine, cosine, and tangent. Now, the last thing we're looking at is lesson 71, your translations. So what do I do with a translation? Now, you had that on your assessment this week. So I want to remind you that a translation is simply a slide. It's just moving right or left, up or down on your X and Y axis. It's simply a translation. So your book is showing you if you have an original shape and I ask you to shift it +2 on the X, -3 on the Y. Each point you're moving X's and Y's. That's what a translation is. So look, it says how to read it. So look on page 473. So if point T is XY, if you're translating it X + 1, you're just adding 1 to the X, and then Y - 2, you're taking away 2 of the Y's. So that's how they translate it. So they give you examples, like example 2, they've taken a right triangle and they've translated it from the third quadrant up to the first quadrant. And notice they put a little etch mark. So X becomes X1, Y becomes Y1, right? So they just put those little etch marks. Now, showing translations with vectors is actually pretty interesting because it turns it into a 3D shape. That's on page 473. Now, let's look at your practice. It says a line segment has endpoints. A is 11.5, B is 4.9, and it's translated 5 units up. What are the coordinates of A, A1, and B1? Well, if it's just translated 5 up, that means, let's think about that. If it's translated 5 up on an axis, if it's just going up 5, then this is my X, this is my Y. So my X would stay the same. It would be Y + 5 because I'm moving it up 5 on the Y axis. So all you're doing is taking those points. So A was 11.5, now becomes A1. I'm going to add 5 to it. It would be 11.10. So the new A1 just moved up 5 units. All right. So it's very important to understand what it's asking of you and then see what to do there. So A1 would just be 11.10. So you do the same thing with the next point, 4.9. So B is 4.9, and I'm moving it to B1. So I'm just adding 5 to the Y. So it would be 4.14. And that's all that your book is showing you. A translation is just a shift, right? In this case, it went up. You can also have it move on the x-axis. All right. And then your other practice problems, B, C, and D, are all written there. So you guys can take a look at those and see how to set those up. All right.